Welcome everybody. I Shriram Dandekar welcome all of you on behalf of Navakokan Education Society's DBJ College Chiplun. We are studying 11 Commerce Mathematics Section 2. We have finished lesson number 1 and in the lesson number 2 of dispersion we have studied the range, the quartile deviation, variance and standard deviation. Also we have solved some problems from exercises 2.1 and 2.2. Let us continue our study further. The next article is standard deviation for combined data. If sigma 1 and sigma 2 are standard deviations and x1 bar and x2 bar are the arithmetic means of the two data sets of sizes n1 and n2 respectively, then the mean for combined data is xc. C stands for combined. xc bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2, and the standard deviation for the combined series is sigma c, sigma combined, is equal to square root of n1 into bracket sigma 1 square plus d1 square plus n2 into bracket sigma 2 square plus d2 square completely divided by n1 plus n2, where this d1 is equal to x1 bar minus xc bar and d2 is equal to x2 bar minus xc bar. The mean of first data minus combined mean is d1 and mean of second data minus combined mean, it is d2. These values are used here in finding this standard deviation of combined data. Let us see the solved examples. The mean of two samples of sizes 10 and 20 are 24 and 45 respectively, and the standard deviations are 6 and 11. Obtain the standard deviation of the sample of size 30 obtained by combining the two samples. Given that square root of 19067 is equal to 138. Now here first of all we are going to write the given things. The means of two samples of sizes 10 and 20, that means n1 and n2 are given. n1 is 10, n2 20, and the means are 24 and 45, that means x1 bar is 24, x2 bar is 45. The standard deviations are 6 and 11. So sigma 1 is 6, sigma 2 is 11. Now we have the formula for combined mean. xc is equal to n1 x1 bar plus n2 x2 bar upon n1 plus n2. It is equal to 10 into 24 plus 20 into 45 divided by 10 plus 20. It is 38. So the combined mean is 38, and now combined standard deviation using the formula sigma combined is equal to square root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. Now here d1 is x1 bar minus xc bar, that is 24 minus 38 equal to minus 14, and d2 is x2 bar minus xc bar, it is equal to 45 minus 38 equal to 7. Putting all the values in the formula, we get sigma combined is equal to square root of 10 into bracket 6 square plus negative 14 square bracket complete plus 20 into bracket 11 square plus 7 square divided by 10 into 20. This calculation gives us the answer square root of 190.67. Now here we have given the value square root of 19067 is equal to 138. This value is provided in the data and therefore we can use it. Square root of 190.67, I have shifted two decimals towards left, so in the square root only one decimal place I have to shift, 13.8. So using the same 1.9067, it is equal to, now here I have shifted the decimal towards left 4 points. So after finding the square root, this decimal is shifted to 2 points. So 1.38 is the square root of 1.9067. Now in our case it is the square root of 190.67, so it is equal to 13.8. Suppose we have to find square root of 1906.7, then we cannot use this value. Please note this. The second solved problem is, the first group has 100 items with mean 45 and variance 49. The second, if the combined group has 250 items with mean 51 and variance 130, find the mean and standard deviation of the second group. Like the previous problem, similar technique is applied here. Only thing, the second group values x2 bar and sigma 2 are not given to us. Firstly, first group has 100 items, so n1 is equal to 100. First group has mean 45, so x1 bar equal to 45, and first group has variance 49, that means sigma 1 square equal to 49, that is sigma 1 is equal to square root of 49 equal to 7. And also for the combined data, n is equal to 250. xc bar is equal to 51. Now we know that n1 plus n2 is equal to n, and therefore 100 plus n2 is equal to 250. This implies n2 is equal to 150. Let us see the same is there or not. N is equal to n1 plus n2 implies n2 is equal to 150. This we have just seen. Now xc bar is equal to n1 x1 bar plus n2 x2 bar upon n1 plus n2. Putting the values of n1 x1 bar n2, here we get the value of x2 bar calculated to be 55. The combined standard deviation is given by, this formula is not used for standard deviation, this is variance. So let us correct this, correct in your book. This is not standard deviation, this is variance. The combined variance is given by sigma square c is equal to n1 sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. Now d1 we can calculate, d2 we can calculate, d1 and d2 minus 6 and 4. Putting the values, we get sigma 2 square is equal to 144, and therefore sigma 2, that is standard deviation of second group, is equal to 12, and the mean of the second deviation we have already found out, it is equal to 55. Next point is coefficient of variation. The standard deviation depends on unit of measurements. It is therefore not useful for comparing series of data measured in different units. Coefficient of variation is independent of the unit of measurement and hence it is defined by CV, coefficient of variation, equal to 100 into sigma upon x bar. If different units are used, we cannot compare them unless we know the exact relation between the two units. Therefore, we cannot directly compare the two data when they are using different units. For example, if the first data uses height of the students and they have mentioned the heights in feet and inches, and the second data gives suppose the heights in centimeters, then to compare these two data we always need the always need the relation between feet and centimeter, and always we have to convert them. To avoid this, to compare two datas, we need only the coefficient of variation, whose formula is coefficient of variation equal to sigma upon x bar into 100. The coefficient of variation is used to compare the variability of two distributions. The distribution with smaller coefficient of variation is said to be more homogeneous or compact. More homogeneous or compact. And more consistent or steadier, and a distribution with larger coefficient of variation is said to be more heterogeneous or more variable. So smaller coefficient of variation means the data is more consistent or steady, and larger coefficient of variation means the data is heterogeneous or more variable. The first problem, the arithmetic mean of runs scored by three batsmen Varad, Viraj and Akhilesh in the same series are 50, 58 and 21 respectively. The standard deviation of their runs are 11, 16 and 5 respectively. Who is the most consistent of the three? If one of the three is to be selected, who will be selected? Solution: let x1 bar, x2 bar, x3 bar and sigma 1, sigma 2, sigma 3 be the means and standard deviations of the three batsmen Varad, Viraj and Akhilesh respectively. The given things: x1 bar is 50, x2 bar 52, x3 bar 21. Sigma 1 11, sigma 2 16 and sigma 3 5. Now the coefficient of variation of the runs scored by Varad is equal to sigma 1 upon x1 bar into 100, that is 11 by 50 into 100, it is 22%. Coefficient of runs scored by Viraj is 27.59 using the same formula, and using the same formula the coefficient of variation of the runs scored by Akhilesh is equal to 23.81. Now here observe that the CV1 is equal to 22%. CV2 is equal to 27.59 and CV3 is equal to 23, and therefore the CV1 is smallest than CV2 is smaller than CV2. CV3 is the middle one. 23.81 means it is the middle one. Now from this, CV1 is smaller, therefore the first batsman is more consistent than third, and third batsman is more consistent than the second batsman. Since the coefficient of variation of runs is smaller for Varad, he is the most consistent player. To take decision regarding selection, let us consider both coefficient of variation and means. Based on consistency, since CV of Varad is smallest, he is more consistent and hence is to be selected. And if we are expecting the score, then based on expected score, if the player with highest expected score is to be selected, then Viraj will be selected because his average x2 is greater. Hence, one has to take the decision according to the situation needed. If we are considering only the consistency, then Varad is best, and if we are considering the expected score, the highest average is of Viraj, hence he will be selected. The following values are calculated in respect of prices of shares of companies X and Y. State the share of which company is more stable in value. Company X, that is share of company X, its mean is 50 and variance is 7, and share of company Y, its mean is 105 and variance is 4. Now sigma square is equal to 7, so sigma x is equal to square root of 7, calculated using log table 2.64. Sigma square y is 4, so sigma y is equal to 2. X bar is 50, y bar is 105. Let us find the coefficient of variation for both the companies. CV of x is sigma x upon x bar into 100. It is 5.28%, and CV of company Y is equal to sigma y upon y bar into 100. It is equal to 1.9%. CV of Y is less than CV of X, hence share of the company Y is more stable in the value. Let us see exercise 2.3. The mean and standard deviation of two distributions of 100 and 150 items are 50 and 55 and 40,6 respectively. Find the mean and standard deviation of all 250 items taken together. Now in this problem, this 100 is N1, 150 is N2, mean, that means this 50 is X1 bar, 5 is standard deviation, that means sigma x, 40 is X2 bar, and 6 is sigma y or sigma 2. Let us call this as sigma 1 5 and sigma 2 6. Now 250 is n. Now use the formulae xc bar is equal to n1 x1 bar plus n2 x2 bar upon n1 plus n2. Then find d1 is equal to x1 bar minus xc bar, d2 is equal to x2 bar minus xc bar, and to find the combined standard deviation, use the formula sigma c is equal to square root of n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. Use this and find the required values. The problem is very easy. The second problem is, for a certain bivariate data, following information is available. For the variable x, mean is 13, standard deviation is 3 and size is 10. For the variable y, mean is 17, standard deviation is 2 and size is 10. Obtain the combined standard deviation. It is exactly the similar problem just like previous first one. This is x1 bar, this is y1, this is x bar, this is y bar, this is sigma x, this is sigma y, this is n1, this is n2. Now you find out the combined mean and find out the combined variance, similar to the previous problem. So it is left as an homework. Let us solve this third problem. Calculate coefficient of variation of marks secured by a student in the exam, where the marks are 2, 4, 6, 8, 10. Firstly, we will calculate x bar. X bar is equal to 2 plus 4 plus 6 plus 8 plus 10 divided by 1, 2, 3, 4, 5 equal to 30 upon 5 equal to 6. Now sigma square is equal to 2 minus 6 square plus 4 minus 6 square plus 6 minus 6 square plus 8 minus 6 square plus 10 minus 6 square divided by 5 equal to 16 plus 4 plus 0 plus 4 plus 16 divided by 5 equal to 20 plus 20 40 by 5 equal to 8, and therefore standard deviation equal to sigma equal to square root of 8 equal to 2 root 2 equal to 2 into 1.41 equal to 2.82. Standard deviation we have found out. Now we want coefficient of variation, and its formula is coefficient of variation is equal to sigma upon x bar into 100 equal to sigma is 2.82, x bar is 6 multiplied by 100. It is equal to 0, 6, 4 za 24, 6, 7 za multiplied by 100, so it is 47%. The answer given in your book may be incorrect. This one is correct for this given data. This fourth problem is very easy. CV is required, mean given and standard deviation given. So directly the formula sigma upon x bar multiplied by 100. Question number 5. A group of 65 students of class 11 have their average height is 150.4 centimeter with coefficient of variation 2.5%. What is the standard deviation of their height? Now in this problem, coefficient of variation is given, that means sigma upon x bar into 100 is given 2.5. So sigma upon x bar is also given 150.4 multiplied by 100, it is 2.5. Now from this you can find out the unknown sigma, that is the standard deviation of height. It is equal to, sigma is equal to 2.5 into 150.4 divided by 100. You do the calculation yourself. Sixth one, two workers on the same job show the following results. Worker P, mean time and standard deviation. Worker Q, mean time and standard deviation are given to us. Let me decrease the size of this. Regarding the time required to complete the job, which worker is more consistent? Which worker seems to be faster in completing the job? Just now we have seen one problem of batsman. Which batsman is consistent? Using the same argument you can solve this problem. Here mean time, that means for the first data x1 bar is given, here x2 bar is given, standard deviation means sigma 1 is given and sigma 2 is given. From this find out the coefficient of variation. Now regarding the time required to complete the job, worker is more consistent. Clearly worker Q has the mean smaller than worker P. So worker Q can do the job faster. Now this first answer, which worker is more consistent, its answer is given by coefficient of variation, which you are going to solve. Very easy problem. Question number 7. A company has two departments with 42 and 60 employees respectively. Their average weekly wages are 750 and 400. The standard deviations are 8 and 10 respectively. Which department has larger bill? Which department has larger variability in wages? Now CV, whose CV is greater, that department has larger variability in wages. And which department has the larger bill? The department whose to find out the bill, just weekly average wages multiplied by number of the employees will give you the bill amount. So 42 into 750, compare it with 60 into 400 and then decide which department has the larger bill. Also coefficient of variation will give you the larger variability of the wages. I hope you can solve this problem easily, and certainly if you are unable to solve or if you have some little doubt, then you can ask me on my WhatsApp number. The next problem is, the following table gives weights of the students of class A. Calculate the coefficient of variation. Weight in kilogram: 25 to 35, 35 to 45, 45 to 55, class A. Their frequencies are given. Now we have to find out the coefficient of variation. Let us solve this on our board. I have copied the problem on board. Let us solve this. let us continue this table. Now this is class given to us. Frequencies are given to us. Let us write one column for class mark. 25 to 35, that means class mark is 30, 40 and 50. The class marks we have written. Now since we want coefficient of variation, we need sigma to calculate. So next I am going to find out xi into fi, but for that I will use the step deviation method, which is beneficial for me. Ui is equal to xi minus 40 divided by 10. So this is 0, minus 1 and plus 1. Ui into fi minus 8, 0, 8. Ui square into fi, minus 1 square is 1, 1 into 8 is 8, 0 and 8. Summation ui fi is 0. Summation ui square into fi is 16. So u bar is equal to summation ui into fi divided by n. This summation fi is n, it is equal to 20. This is 0 upon 20, 0. So u bar is 0, and therefore from this I can conclude that x bar is equal to 10 u bar plus 40. It is equal to 40. 40 is the mean of the variable x. Now sigma square u, it is equal to 1 by n summation fi into ui square minus u bar square 1 by 20 into 16. This is equal to 0.8, because u bar is equal to 0. Sigma square u we have found out, and therefore sigma square x, it is h square into sigma square u. We have divided by 10, so h square is 100 multiplied by sigma square u, that is 0.8. So sigma square x is equal to 80. Sorry, yes, 80. And therefore sigma x is equal to square root of 80. It is given that square root of 0.8 is equal to 0.8944. So square root of 80 is equal to 8.944. Sigma x we have found out. We want the coefficient of variation, which is equal to the coefficient of variation CV is equal to sigma x upon x bar into 100, that is 8.944 divided by 40 into 100. 1 0 cancels out, equal to 2 2s are 4, 2 2s are, sorry, 4 2s are 8, 4 2s are 9, 1 remaining, 2 4 3s are, and 4 8s are. So CV, coefficient of variation, is 22.38%. Let us solve this ninth problem. Compute the coefficient of variation for team A and team B, given that square root of 26 is 5.099 and square root of 22 is 4.6904. I don't know whether these values are useful or not. Number of goals scored and number of matches played are given here by team A and by team B. I will explain this table. Team A, in 18 matches they have scored 0 goals. In 7 matches they have scored 1 goal. In 16 matches they have scored 3 goals. Team B, in 16 matches they have scored 1 goal, and so on. Which team is more consistent? For that we have to find out the coefficient of variation, and for coefficient of variation we have to make a table. We have to find variance and then x bar and then coefficient of variation. Let us make a table. Xi, in this Xi column I am taking the number of goals scored 0, 1, 2, 3 and 4. In the column F1I, it is the number of matches played by team A. For scores, for the goal number 0, they have 18 matches played. I will write all over here: 18, 7, 5, 16, 14. F2I, 14, 16, 5, 18 and 17. Let us add these: 18 plus 7, 25 plus 5, 30, 30 plus 30, 60. F2I, 30, 35 plus 35, it is 70. Now Xi into F1I, 0. All entries in this column are 0 because x is 0. Now Xi, 1 into 7, 7, 2 into 5, 10, 3 into 16, 4 into 14. Addition of these: 1 carry 2, 11 and 12, 121. Xi into F2I, 16 into 1 is 16, 5 into 2 is 10, 54, 68. Addition is 8 carry 1, 7 plus 7, 148. Xi square into Fi, 1 square is 1, 1 into 7 is 7, 1 into 16 is 16. 2 2s are 4, 4 5s are 20 and 4 5s are 20. 3 3s are 9, 16 9s are 144 and 18 9s are 162. For 16, 4 4s are 16, 16 into 14, 224, and 16 into 17. Let us add 7 plus 8, 5, 15, carry 1, 7, 8, 9, 395, and this addition 4 plus 6, 0, 10, carry 1, 470. These additions are taken. Now we want the means. For the team A, mean XA bar is equal to summation F1I into Xi upon N1. This is N1. This is N2. 121 upon 60. I will approximately take it as 2. Actually it is 2.01, but I am going to take it as 2. XB bar summation F2I Xi upon N2, it is 148 upon 70. It is equal to 2.1. I will approximate this as 2.1. I will forget the remaining digit. Now sigma square A is equal to 1 upon N1 summation F1I into Xi square minus X bar XA bar square, that is 1 upon 60 into 395 minus 2.01 square. This is equal to, now, 6.58 minus 4.04. So I am going to write this as 2.54. This is sigma square A. Sigma square B is equal to 1 upon N2 summation F2I into Xi square minus X bar B square. It is 1 upon 70 into 470 minus 2.1 square. It is 2.3, and therefore sigma A is equal to square root of 2.54. It is equal to 1.59, and sigma B is equal to square root of 2.3. It is 1.51 approximately. Now we want the coefficient of variation. For team A, it is equal to sigma A upon XA bar into 100. Sigma A is 1.59. XA bar is equal to 2.01. This works out to be 79.10, and CV for team B is sigma B upon x bar B into 100. It is 1.51 divided by 2.1 into 100. It is equal to 71.90. As CV for B is smaller than CV for A, team B is more consistent. Team B is more consistent. Here also the problems in the answers in the book are not matching with the answers of this, but our calculation is correct so far, and therefore you can take this as the answer. This 10th problem given below is the information about marks obtained in mathematics and statistics by 100 students in a class. Which subject shows highest variability in marks? This is similar to one of the solved problems. Using that technique you can solve this problem. This is again for homework. Now we have finished almost all topics in this lesson. Only remaining thing is the miscellaneous exercise 2. Now from this miscellaneous exercise 2, if there are doubts, you will ask me in our online session, live sessions. These are recorded lectures I am providing you, but here I am not giving any problem or any solution to the problems in the miscellaneous exercises. They are for homework. You solve them and ask them in our live sessions of online learning, or when the college starts after this corona pandemic, we will see these miscellaneous exercises. So for today I take a pause, and we will meet in the next lesson, next article. Thank you very much.